Everybody, we have an equation that involves the sigma function, which is the sum of the divisors function. So let's work a concrete example. Let's say 14 maybe, okay? Now, the sigma function is what they call multiplicative. I'm not going to try to prove that. As long as the two inputs are relatively prime, you can split this thing apart. So sigma of 14, that we could just physically write this out, but this is also equal to sigma of 2 times sigma of 7. That's what they call, it's multiplicative because the two inputs here are relatively prime. Okay, 2 times 7 is equal to 14. 2 and 7 are relatively prime. They're not only prime numbers, but they're relatively prime, of course. All right, now, a way to do this, and again, this is proven in a lot of number theory books, is just take this prime number and increment its exponent by 1. So you would get 2 squared. Now I'm showing you the hard way because the hard way is what we're going to need to solve this problem. You put 2 minus 1 here. Okay, so it's a nice little pattern based on a finite geometric series. Okay, now similarly for 7 you would get 7 squared minus 1 over 7 minus 1. Okay, now this looks like, what do we got here, folks? This would be 4 over 1, so this is equal to 3. Okay, now let's go ahead and do this in our head. 7 squared is 49. 49 minus 1 is 48. 48 divided by 6 is 8. So we get 3 times 8 is equal to 24. Okay, now you're saying, wow, that looks dumb. And well, first of all, I think I could prove this, but let's just write down what it is directly. All of the divisors of 14, we need to add them up, so that would be 1 plus 2 plus 7 plus 14. Those are all the divisors of 14. You can see this is 14 plus 7 is 21, 23, 20, so this equals 24. So you see, for small numbers, it's easy just to enumerate the divisors. Wait. That should be 24, my bad. 1, 2, 7, 14. No, my bad. And these all add up to 24. I don't know what I'm saying. 14 plus 7 is 21, plus 2 is 23, is 24, right? So they line up, right? Now, so let's take a look at how we're going to use this result right here to actually solve this problem. Now, again, the multiplicativity only applies if all of the inputs are coprime or relatively prime. And so we can split this 119x apart, all right, because 119 and x are posited to be coprime or relatively prime, all right? So this is just all that work. We split it all apart, okay, and this is what we get. Now, again, just the same thing I did before. You square, subtract 1 in the numerator, then you just take the difference of the prime number and 1 in the denominator, and similarly right here. So what you get right here is 8 times 18 when you do that, and you guys can verify that. 17 squared is 289 minus 1 is 288 divided by 16 would be the 18 that you see right here. Now, this is equal to 144. 8 times 18 is 144, right? Times sigma of x. Now, we are trying to find x, right? So this is sigma of x right here. Okay, but notice this is equal to from our given 208x. So let's just write it over here. Okay, now we're getting somewhere, it looks like, folks. If you divide through by 144, you're going to get sigma of x is equal to, if you divide it all out, you get, there's a common factor of 4, I think, so you would get sigma of x is equal to 13 over 9 times x. Now remember, we know that sigma function has to return an integer. So what does that imply? Okay, that implies that x would have to be some multiple of 9. So we can write down x is equal to 9n. And again, y'all, the reasoning is this, where n is equal to 1, 2, 3, 4. N's just a natural number. So x is equal to 9n, and sigma x does have to, it sums up a bunch of integers, namely the divisors. So it's going to be an integer, and so for 13 over 9x, the product to be an integer, x has to be equal to 9n. So let's attempt the very first try. For n equals 1, you would get x equals to 9, right? That implies x equals 9. Now we got to check this, right? This is a possibility, but we still have to check the result. Okay, so let's take x equals 9 up here. Again, we just found out, we're checking the answer. We found out that x is equal to 9. So this would break out into 7 times 17 is 119. We've already seen that, right? So you would get sigma of 7. Let me just write it down. Sigma of 7. And we're doing the multiplicative nature of the sigma function here. We're applying that property. So sigma 19, excuse me. And then we think that x could possibly be equal to 9. So we go sigma of 9. But that's sigma of 3 squared, right? Right, folks? 9 is the same as 3 squared. Okay, so let's do our handy-dandy little formula here again. This would be equal to 7 squared minus 1 over, I'll just write 6 this time, okay? So that's 7 minus 1. What do we have right here? 19 squared. Or wait, y'all, that's supposed to be 17, I'm sorry. That's a 17, my bad. 17 right here. 7 times 17 is 119. I guess I'm just saying 19 and writing it down. But that's 7 times 17. So now this would be, again, 17 squared minus 1 over 16. And then times 3 cubed minus 1 over 2. Okay, now let's see. What do we get some of that work done already? That's 8 times 18, right? We've already done that, so that's 8 times 18. So this would be equal to, let me just write it to the right here, folks. 8. That's what this is, right? 8. Okay, this is times 18. Okay, now what do we have here? 3 cubed is 27 minus 1 is 26. So it would be 8 times 18 times 13. Okay. Now, 8 times 18 times 13 is equal to, and y'all, I did this, it's hard to do in your head, but it's 1872. But notice that right here, that 208 times 9. So you see we've checked it. 208 times 9 is equal to this 1870. Let me circle both of these. Okay. We use the formula, the multiplicative character of the sigma function to get the 1872, but 9 times 208 is also equal to 1872. Okay. So we have found one solution. That's all we found so far is one solution. But I will argue that the other multiples of 9 would be too large. And you guys can verify that if you want. But if you tried, say, 18, you would get a larger number here that would split into primes, and there's no way you're going to get the 18. It's not going to work out. Okay, and you guys can verify that on your own if you feel like it. But in any event, that takes care of business here, folks. X equals 9 is the only solution. I didn't only proved it for 9, but again, you could try it. If n were equals to 2, you would get 18. And you guys can verify that that doesn't work. Okay, n equals 2 would lead to x equal to 18. And again, you check it out yourself, and you'll learn that it doesn't. That this is the only one that works. Okay. All right, folks, I guess that's it. Thank you for viewing.